Hello everyone, welcome to the first lecture of 216. My name, Muhammad Zishan Beg. I go by my middle name, so feel free to call me Zishan. Not that I'm ashamed of my first name, but it's always been the case that I've gone by my middle name. My family, friends, everyone calls me that. So I'm going to start off with chapter 3. Not that I don't think that chapter 1 and 2 are important, but they're basics. I mean, the second first chapter is just a starter. There isn't much meat there. The second chapter is about object-oriented design, and since this is the second semester of programming, by now you ought to know these basic concepts, including the object-oriented design, right? You probably must have talked about what's a procedural program, what's the object-oriented program, and what's a design, etc. So you can read through it if you want, but like I said, if you've taken a previous course and you've done fairly well in it, there shouldn't be an issue. Now, in the syllabus, I did mention that you can use the C++ book or the Java book, but stick to the same book. I'm gonna try to stay away from examples, but it's really hard. And the examples I'm gonna show you is the C++ example. Although the syntax for Java is very similar, but if you feel um, But if you think that, look, it might be a problem for you in the future, then just stick with the C++ book. Start with C++ and then just stick with it. I thought about making it language neutral and having it content this way, but uh, but it's really hard though to actually go through without any examples, right? And I've got a bad case of flu right now, so that's why I sound very stuffy. So chapter 3, we'll talk about arrays, uh, multi-dimensional arrays, linked list, singly linked list, doubly linked list, circular linked list, and recursion. And I'll see how much we can get through in this lecture. I try to keep the lectures to half an hour, but sometimes I cannot cover everything in that half hour. So then after this, I'll cover it in the next lecture. But I'm pretty confident that everything minus the recursion we should be able to cover. So arrays, and you might have touched on this in your previous class as well, or previous semester. What is an array? Why need an array? An array is really basic though. An array is a container. It's a holder. It's a placeholder. Now in this case, it's an array in C, but array in C and C++ are about the same thing. Um, Outside of syntax, the memory usage storage are the same. Um, so this case, you have 6 elements, right? So you've got a container for 6 elements, 6 buckets, 6 container, however you want to think of it. But pictorially, look at this in your, try to picture this in your head. And when you close your eyes, you should see this picture of array. So whatever size that you choose, you know, 5, 6, 7, 8, whatever, you'll get that many types of container. Now, each array, the way you access an array is by using the index of the array. And always keep in mind, the index starts at 0. It does not start at 1. It starts at 0. You might be quizzed on this, so make sure you remember. And see, this one's got 1, 2, 3, 4, 5, 6 elements, but the last index is 5. If you use the array at index 6, it's going to throw out of bounds exception. So be careful. So here, I've got a declaration, two different declarations. So the first one is int, and then the second one should be lowercase I as well. It's a case of autocorrect. Microsoft's thinking, wow, I know better, but in this case they don't. Okay, so the first one is um, an index of 6 items, right? So it can hold up to 6 items. Doesn't necessarily mean that you have to put 6 items in there. Um, and one thing to remember is you can have multi-dimensional array. My second example is a two-dimensional array, right? So you've got eight rows. Well, it's 10 and 20, not 8 and 10. I think the comment I initially had it 8 and 10, but never mind. It's 10 and 20. So it's a two-dimensional array. And I'll show you an example of printing items in a multi-dimensional array, what it looks like. But nonetheless, you can have one-dimensional, two-dimensional. You might be thinking, well, what about X dimensions? Yes, that is true. You can have as many number of dimensions as you want, but depends on your use case. Sometimes it's, the more dimensions you have, the harder it is to manage. Okay. Now watch this. I've got a two-dimensional array here. All right, how many rows and how many columns do I have? Right, 4 and 2. I've got 2 columns and 4 rows. And the way I initialize it is by this. So, it's 2 columns, right? So 10, 11, 20, 21, 30, 31, 40, 41. And you can do this for n-dimensional array. And then if you want to output it, you start at 0, you go up until 4th. Depending on the dimensions, the number of dimensions equals number of 4 loops. It's as simple as that. So you want to go 4 rows, and then you want to do 2 columns, right? So the outer one is the number of rows, inner one is the number of columns. You start off at 1 and go till 4. Here you start off at 0 and then go till 4. And then here you start off at 0 and go till 2. And then the output. Right? And you see this. Pretty simple, straightforward. I hope it's making sense. I always say if you have trouble understanding or going through this, try your own examples. I always tend to be 1, 2, or 3 dimensional. I haven't really shown examples of more than 3 dimension. And I think even in my use, I don't think I've ever had a real life example where I've had like 10 dimensional array. And don't remember using, well, vectors is something that I've used more often, and we'll talk about that later. But understand the arrays are there and how you work with multi-dimensional array. And excuse me. And one thing to keep in mind is when I'll show you examples, I haven't logged into the terminal, the Unix terminal that they have. I'm using an online compiler. I tend to use this one, and there's another one. There's 2 of my favorite. And I think I should post this up on the website, but these are the 2 that I tend to use very often. And they're my favorite. You can use them if you want, but I'm not going to hold you accountable for a programming language or a compiler. Use whichever compiler you want. Use C++ or Java. It's the concepts that are more important. The concept of a multi-dimensional array, usage of array, outputting an array, versus the type of language that you choose. Now, that's enough for arrays. The next thing I want to jump into is a linked list. Now, all of these things that we're talking about, they are holders, placeholders, containers for you to put stuff in. Ignore the head for now. There's a head and a tail concept in a linked list, but I'll try to keep it simple. A linked list is a list of items. Okay, the list you define the number of items that go in there, the maximum number, the minimum number, whatever, however, so the bounds that you determine. Now, the way the linked list works is it's got 2 things. Okay. Now, in the array, you can only have, it was an int of integers, right? Integers, and then 4 containers. If you have 4 integers, in this case, you've got a linked list of 4 elements. Now, the unique thing about this thing is it's got data and next. Okay, so it's got 2 places, a placeholder, I should say. It's slightly confusing to explain this, but bear with me. Okay, a picture is worth 1,000 words. So look at this. I've got A, B, C, D. I've got 4 characters. Okay, and what's next? So the container has 2. It's got a partition in it. Okay, it's got a placeholder for data, which is a character, and then it's got a pointer to the next element. A pointer, a pointer is just a pointer. So next, point to the next bucket. next container. And in the next container, I've got B. But B pointer, the next pointer, is going to point to the next element. And then I've got C. C's next pointer is going to point to D. D's next, I want you to hear this clearly, right? Pay attention. D's next pointer is null. And if you haven't guessed, if you're iterating through the list, you start off with the first item and you stop when your next pointer is equal to null. Okay? So that's how you know you've reached the end of the list. Okay, so now I'm going to talk about all these are the examples. Let me go back to the slides here. Um, the doubly linked list. So the single linked list, right? I said there's a pointer to the next element, right? There are two parts of the container. One is the data itself, and one's the pointer to the next one. Now, the one thing to keep in mind is a lot of the times in the illustrations, you will come across a head and a tail. A head's just the beginning, and the tail's the very end. Or a head and tail, you know how it is, right? A picture a head and a tail. So heads, the body starts off at the head, and tail is where it ends. Not a human body, but for animals, because human beings don't have tails. We get the point. That is a singly linked list, right? Because where you have, um, uh, well, one thing to keep in mind for the single linked list is the element three right here is going to point to null. But for illustration purposes, just think of it as a tail. And then in the doubly linked list, what happens is you've got three portions to the container. One is a pointer to the next element. The other is a previous pointer to the previous one. And this happens for everything. Now, one thing I wanted to point out here is in the doubly linked list, it's very easy to add and remove elements. How are you going to do that? You're going to make this next point to an element. Oh, so you create a brand new element. You point this next element to that new element and this previous to that new element. So that's the easy, and it's the same thing to remove elements too. Adding and removing from a doubly linked list is very easy and straightforward. I hope you're getting the point of this. Gosh, I wish I had like real life examples, or actually the reasons why I went with doubly linked list. Like I said, I haven't really. I've used arrays. I've used vectors. I haven't really come across linked lists that much in the code, honestly. Maybe legacy code. Actually, I think legacy code does have linked lists on their usage, but oh yeah, this is where the data structures all come in handy. I can tell you this, and when it comes time for interviewing, and I interview somebody and I look for a data structure that's going to perform faster. Right now, we're not talking about the O of N or the how fast it performs, but at some point we're going to talk about it. Where this data structure versus that data structure, how does it perform faster? Is the search faster? Is the sorting faster, etc.? That's where these data structures come in handy. But coming back to this, the difference between the single and the double is double has two pointers. Think of it this way, where a single has single pointer. There is a third kind of linked list, which is called a circular linked list, and all it is the last element. The this is a circular linked list, but it's a circular double linked list, if I may say so. So the last element points to the very first one. So you can keep circling in this. And you'll see later why a circular linked list is of use. But let me walk you through. Well, before I do that, let me share this container of a single linked list. What is it going to look like? I said it had two parts to it, right? One is the data itself, and one's the pointer to the next element. Now a double linked list, the only difference between a single and a double linked list is you've got a pointer to the previous and the next one in a double linked list. Now one thing to keep in mind is the single linked list, the node of that is the same as the circular. Well, it could be. If it's a circular single linked list, then the node is going to be the same as that of a single linked list. But if it's a doubly linked list, then the node's going to be different. So this same node is going to apply to a single linked list and a circular linked list. Now let me go ahead and walk you through some examples. So this one is that was I'm sorry, excuse me. That was a circular linked list. Let's start off with a single linked list. Now the node you saw is a class node. Um, like actually that the previous example was struct, but I made it a class just for simplicity's sake because some of you I hope you know struct. If not, ping me, email me, and I'll explain it to you. Or maybe I'll cover it in one of the lectures if there's enough people that don't know what structure is. Okay, so you've got a data portion to it, and then the next, and then I've got a print list that all it does is it takes in the node n, while n is not equal to null, and a data, and then it moves n to the next one. And remember, in the single linked list, the very last element, right, the pointer, there is data in there, but the pointer is pointing to null. So what's going to happen is when you try to print one after the other, and up until null, it's going to output everything. And then I've got a driver, the head, the second, and the third. So I've got three elements. So I allocate three nodes. Head at data at 1 is 1. The head at next, so the next pointer is going to point to the second element. Second element's got 2. And second dot at next is going to point to third. Hopefully I don't have any syntax over there. So see? And the way it did it is right here, right? That last element is indeed pointing to null. So up until you reach null, you keep outputting n at data, and then n is equal to n at next. And at some point, what's going to happen is that n at next is going to equal to null, and that is where the output is going to stop. Double linked list. Double linked list has a pointer to previous one and a next one. Okay, so I've got a method push, and that's going to take it a node and data, and it's going to allocate a new node. Okay, and the definition of node is the same. Well, most of it is the same, except you've got a pointer to previous element as well. Like a new node, new data, new node at next is the head reference, and the previous is equal to null. Change previous of head node to the new node. This is slightly harder to follow, but basically all that's going on in this example is you create a node and you set its data and the next one. Okay? The head reference is a pointer. If that's not equal to null, then head reference at previous equal to new node. This is a way to push elements into this. Now, I suggest if you still don't understand this, let me know and I can explain in more detail or set up office hours with you and kind of go through it. But I think the best way to do this is actually write examples of your own, because in this it's a straightforward example where I'm pushing something and then I'm printing it. But since it's got previous and next node, it's confusing. And then here I've got a function to go through the list. Okay, while node is not equal to null, I say node and data. I'll put that, and then last is equal to node, and then node is equal to node and next. Okay, because keep in mind, since I'm printing it, I have to work with both the pointers, right? The head, the pointer previous one, and then the pointer to the next one. And then it's actually printing the data out in reverse. So here, I start off with an empty list. I insert 6, I insert 7, I insert 1. Let's go ahead and look this. I'm sorry, guys. See, traversal in forward direction 1, 7, 6. And I can even go back 6, 7, 1. See, these pointers to the previous and the next one make your life really easy though, especially when it comes to traversing, or it comes to adding, or it comes to deleting. Now let's look at a circular linked list, okay? Now watch, the node only has one pointer, it's got to point it to the next one. And once again, I have a push and I have a print list. And see how push is pushing things in, allocates a new node, it has a temporary node, right? PTR and data is equal to data, PTR and next is equal to head. Because you need a reference, you need a placeholder, right, for this. So you have this temp node declared right here. If linked list is not null, then set the next of last node. If it's not null, then you set it appropriately. This is a special case, when it comes to, for the first node, it's going to come to the else portion, and then PTR1 and next is equal to PTR. And then headref is equal to PTR1. Now, when it comes to look at the print list. While head is not equal to null, right, then you do temp at data, okay, and then temp equals temp plus next, and you keep doing this, and if you have already assigned this temp to the head, so it's a circular list. Once you've gone through it all, in a single linked list, what was happening was we were traversing all the way up until you hit null. But in this case, you have to go all the way around till you hit the head again. And the first time, for the last, do while, the way do while works is do is actually going to execute at least once. So that's the reason why we have a do loop here. And then I have a main function, right? I push 4 elements into it, and then I'll put it. Now, I'll repeat it again. Have a picture of these linked lists in your head. Play around with an example, and then it'll make things very clear. Just me talking through it. If I were to just talk through it and I didn't know about linked list, I'd be confused. And I remember the first time I went through the linked list, I was confused. The only thing I could understand was a single linked list, the circular, and the double linked list. I think circular was the last thing I was able to understand. It took days, but the single linked list I started off with, played with a lot of examples, made sense. I went to double and then went to single. Since we're doing so good on time, I thought I'll go ahead and cover recursion. Recursion is another one of those tricky concepts that takes a while for folks to understand. I mean, when I'm explaining this, I feel like, oh man, it's easy for me to explain it, but for you guys to get it, and I know because I've been there, it's not that easy. Explaining it is one thing, understanding and usage is completely another thing. But I'll try my best. Recursion is the concept of recursively, again and again, calling yourself, where usually the way it works is a function calls itself until a terminal condition is met. So you'll have a main function that's going to call recurse. Recurse is the name of the function. It's going to take in a parameter, and then recurse is going to call recurse itself again and again and again, up until at the end it returns a 0 or a 1. So the recurse function itself is going to branch into other function calls. And then when the last condition is met, then it starts coming back. And the way to understand this is by an example that's been used for decades and still continues to be used today, is hold on, we had an example right here, is the factorial example. And I hope you guys know what factorial is, right? Factorial of 3 is 3 times 2 times 1. Factorial of 10 10 times 9 times 8 times. So you start off at the number, you multiply everything smaller than that up until 1. Okay? Now, obviously, if you had to use if then else, you're going to use all these if then else, or maybe you'll have uh, a lot of duplicate code. You would have had code that's really hard to maintain. But by using recursion, it's just a few lines of code that can be maintained for generations to come. So I want a main function, int n and the result. So I ask the user to enter in a non-negative number, and there's no error handling, so I assume it's going to be a non-negative number. I take in the n, and then I call the factorial method. If it's greater than 1, right, let's say if it's 2, I say 2 times factorial of 2 minus 1, right? So then what's going to happen is the branch first is going to look like this, right? 2. If I can explain it this way. It's going to come in 2 times factorial of 1. It's going to do this. It's going to call itself, right? Otherwise, if it's not greater than 1, it returns 1. Now what happens is, when it comes in the second time, is 1 greater than 1? No, so it's going to return 1. So what's going to end up happening is this call 2 times 1, so you'll get an answer of 2. Now the same thing that happens with 3. 3 is going to call factorial of 2, right? Which in turn will call 2 times factorial 1. Now, when you're at the very bottom leaf, factorial 1 comes back with 1, and 2 times 1 ends up as 2. Factorial 2 came back as 2, right? So then you do 3 times 2 is 6. And you can expand this. You can expand this even further.